Hi, I'm Adam Chalmers. I'm a software engineer at zoo.dev, and this is my KCL tutorial series. KCL, the kitty cat language, is a programming language for doing 3D design. It's a programming language for cat, and it powers our new Zoo Design Studio. So in previous episodes, I've showed you how to get started with KCL, and we've looked at how to make 2D shapes and then how to turn those into 3D shapes. In this episode, we're going to be looking closer at 3D shapes. We're going to be looking at how to do fillets and chamfers, how to transform edges, basically. And then we're probably going to take a look at other things you can do with 3D shapes, like how to transform them, clone them, move them around so you can reuse them easily. So let's get started. Let's start with a basic 3D shape. Let's use just a kind of standard cube shape, let's say. So we're going to do start sketch on, and we will make a square. Let's just use the polygon call. Make a square with side length 10, 4 sides. Cool, we've got our square. And make it a bit bigger. Okay, and now let's make that square into a cube by extruding it. We're going to extrude with length 10, and then that'll make our square into a cube. Whoop, there, where'd it go? There it is. Okay, so now that we've got our cube, let's see what we can do with it. Now I'm going to show you a new powerful thing you can do with KCL, which is called tagging. You can tag an edge. So, you know what, let's not use the polygon call. Let's make our own square so we can get access to each edge. Now we have our cube, and we can have each line. So you see that when we mouse over lines now, if we mouse over this line, we click it, it gets highlighted yellow, and the line of code that corresponds to it was also highlighted. If we click on this line here, you can see the corresponding edge gets highlighted as well. So this kind of bi-directional flow between the code side and the visuals, and then the visuals back to the code, is really powerful. So let's say we want to find out, want to keep a little reference to this edge. Usually you'd reference data by making it into a variable, but because we're building this data inside this pipeline, we can't really break it out into its own variable. What we can do instead, we can tag an edge. Let's just give it a tag. Let's call this side A. So if we want to know what it is, we can click it and we can take a look at it. We see it gets highlighted yellow. If we click the edge here, the line of code gets highlighted in blue. So now that we've tagged an edge, we can then do something to it, like we can fillet it. If we use the fillet call, let's use fillet, we'll put a fillet radius of, let's say 4, and the tag will be tag A. We now filleted away one of these edges. Let's change the fillet, let's make it a little bit smaller, a little bit more even. Filleting is really useful in engineering because, say, you want to print out, you want to manufacture dice, say. You don't want to have super sharp edges. You might want to round those edges away so that people don't cut themselves in your designs. So a little bit of rounding makes designs a lot nicer. And we can apply multiple fillets as well. Let's tag another face as well. Let's tag this one as B, and we can put a tag here as well, tagging this B. So you can see we've got our 2 faces being tagged. We can obviously tag all 4 of these faces here. Now what if we're going to tag the opposite faces, the ones over here? Now, how do we do that? Because this is our original square. These are our original edges that we put in this call here. But these 4 edges over here on this face, these were made by by extruding. So we don't have access to them. There's not a single call here where we can add the tag in. So what can we do? Well, we can use this little helper function here called getOppositeEdge. We give it a tag like A, and it gives you access to the opposite edge. So let's just tag just these 2 faces so you can see in a little bit more detail what we're doing. Here, this is A, and over here, this is the opposite edge from A. So we've tagged it by using the getOppositeEdge. And of course, we can do the same thing. We can tag, we can tag here, we can tag this as B. We can fillet B as well. Oh, we already tagged this as B, so it's complaining because you can't reuse the same tag twice. So we've now filleted 3 faces. We've filleted 3 edges, A, B, and the opposite of A. Now we can do the opposite of B as well. Okay, so we've now filleted away 4 edges. Very nice. Now this is kind of the base face. This is the start face of the extrude. This is the end face of the extrude. What about if we want to fillet away these edges here? These are what we call side edges because they're not on the starting face of the extrude, they're not on the ending face of the extrude, they're side faces that were made in between. Well, for those, we can use I'll show you the function, of get next adjacent edge to A. So we're filleting away both A here, this is A, you can see it because we can click it, and then this is the opposite, the next adjacent edge from A. And we can also fillet away this one here because it's the previous edge. So let's use that. Get previous adjacent edge to A as well. So you see we have access to the kind of base face by tagging them here. And then you have access to the opposite face by using the get opposite edge. And then you have access to the side faces by using get next and previous adjacent edge. So that's how you can access all the different edges in this cube to fillet them away. Now there's another kind of cut you can make. Fillet kind of cuts away in a round, smooth radius. We can also chamfer. So let's keep this cut here. Let's keep this this filleting cut, and let's also add a chamfer. So let's put a chamfer of length 2, and we'll tag face edge B. So here you go. Now you can see the difference between these really clearly. The radius here has been filleted away, and this edge has been chamfered away. So chamfer works very similarly to filleting. You can do all the same kind of things with choosing different faces and different edges by get next, get previous adjacent, get opposite. So that is filleting and chamfering, two useful ways to modify a 3D solid after you've made it. There's some other things we can do as well. So let's restore our, let's keep it like this actually. I like this shape. So we can then rotate and transform our cube. Yeah, let's translate it. You can translate it. Let's translate it by 100 along the x-axis. Oh, where did it go? It went 100 units away along the x-axis. That's where. So here, let me zoom out a little bit. You can see if we then want to translate it also by 50 along y, we can do that. And it just moved around. So we can do y equals 0 translation. It's over here. Y equals 50 translation. And it's going to be over here instead. So it's moving around across the axes. So you can do translations of x or y or z. If you leave out one of those axes, it'll just stay where it is. So if you only want to translate x, that's fine. You can only put x. If you want to translate them all, you can put them all. You can also do scaling and rotation. So let's just restore our basic cube. What if I want to make it bigger? We can scale it. Let's scale it along the x-axis. Let's scale it by 2, making it twice as wide. Let me zoom in a bit so you can see that a little bit better. Let's restore it to x equals 1, which is keeping it the same. X equals 2 means make it twice as long. X equals 10 means make it 10 times as long. Of course, you can scale it down as well. Let's make it half as long along the y-axis. So we've now shrunk it along y. You can see it's pretty small along y now. If we restore it, or let's make it twice as long along y, you can see it's much longer. Let's put it back down to half. And it's much smaller again. And obviously you can combine these two, so we could, keep the translation. We can translate it, 10 units across x, and then we can also scale it. Okay, last thing I want to show off is rotation. You can rotate objects using their roll, pitch, and yaw. So it's 0 to yaw to 10, yaw to 20. So you can see that it's kind of slowly rotating it around this way. Let's set the pitch to be, 45. You can see it rotates it along this way. So you've got a full 3 axes of rotation. The other way you can express rotations is you can just give it an angle and a length, I think. Let me just mouse over it, get the docs. You can see, yep, we've got, what are the optional axes? We can give it an axis and an angle. So let's say the axis equals x and the angle equals 10. Oh, sorry, this it doesn't take in labeled axes. It takes in, an axis like this, like a vector, basically. So rotating it 10 degrees around this. Let's rotate this 90 degrees around it instead. Cool. 45 or 40 is good enough. So yeah, you can see that all these rotations are totally fine. We can see them more easily if we copy this, actually. Let's make this into a function. Let's make this function cube. And we will return this cube here. So now let's make one cube and we'll rotate it 40. Let's make a second cube that's rotated 20. And a third cube that's rotated 60. And there you can clearly see the effect of the rotation. You can see all three cubes, and you can see that they're slowly being rotated around this axis. Here's a cube, here's a second cube, here's a third cube. You can see them smoothly rotating around. So yeah, we've seen how to fillet and chamfer edges. We've seen how to use transformation functions, things to modify your cube, your solids, things like rotating, translating, and scaling them. One last thing to show off. Let's show off the appearance function. So with appearance, you can customize the way the shapes look. Let's make these shapes different colors. Let's make this let's make these 3 different colors, and we're using hexadecimal color codes here. So the first numbers are how red it is, the next 2 numbers are how green it is, and the last 2 numbers are how blue it is. Cool. So we've got 3 different shapes here. You can also change their metalness and their reflectivity. So let's customize that a little bit. Let's make one of them really reflective. We'll make metalness equals 90. These are percentages. Roughness equals 20. So now you can see this one is much more metallic than the other ones. So you can use these to customize the visuals and make your parts a little bit easier to understand. Obviously you can see these 3 are overlapping, so you get a bit of distortion there, but that's not really how you would ever, it's not something you would do in a normal CAD model. Let's just cancel these ones out, let's delete them. And yeah, there you go. So appearance can be really useful for telling which parts are which. They can help make your parts easier to explain, because you can say the pink cube or the shiny cube instead of having 4 or 5 different cubes you can look at. Okay, thanks so much. Hope you enjoyed that episode. We saw how to use fillets and chamfers to smooth away edges on your 3D solids. And then we saw you can move the solids around in space by scaling them, translating them, rotating them, or even changing their appearance. So stay tuned for the next episode.